Hello everyone. We now move on to the second lecture on armamentarium for local anesthesia. The topic is needle, and yes, the absence of needle as well. A needle by definition is a thin, hollow and sharp-pointed piece of metal which is used to inject local anesthetic solution into the tissues. In addition to the description about the different types of needles, this lecture will also feature demonstration videos of parts and assembly of a needle and the use of jet syringe or needleless syringe. It is interesting to note that needle was invented many years after the invention of the syringe. The first modern syringe was invented by Pascal in 1650. And the first hollow steel hypodermic needle was invented by Rind in 1844. The dental needles much later. Till then, syringes were used only for irrigation. On that note, let's move on to the description about dental needles of today. One of the key features of a dental needle is its sterility. To minimize the risk of infection, dental needles are pre-packaged in sterile conditions, ensuring that they are free from harmful pathogens until use. Many dental needles are designed to be disposable, meaning they are used only once and then safely discarded. This practice prevents cross-contamination and upholds hygiene standards in dental clinics. Dental needles are typically made of stainless steel, a material known for its strength. The choice of stainless steel ensures the needle remains sharp and durable, making it capable of penetrating tissues with minimal discomfort to the patient. Moreover, stainless steel is resistant to corrosion and heat, which is crucial for the longevity and hygiene of the needle. I'm going to start with needle for cartridge syringes because these are exclusive to dentistry. These needles come as a package in the form of a sheathed needle. The basic parts include the needle, cap, hub, and a syringe adapter. Now I'm going to demonstrate the parts of a needle in detail. The needle consists of two ends. The longer end is used for injection and the shorter for piercing the cartridge, and both the parts are completely sheathed. The needle is sterile and kept in a housing. The housing is twisted to release the seal and expose the shorter end first. This is how it is done. Now the needle is screwed on to the hub of the syringe. Notice that the shorter end is screwed on to the hub of the syringe. This pierces the anterior rubber diaphragm of the cartridge. With gentle twisting motion, you secure the needle to the syringe. Once the needle is fastened to the syringe, you're ready to go. In contrast to the cartridge syringe needle, the needle of the disposable syringe has only one end, while the parts remain the same with a hub, shaft, and a bevel. Also, these needles come with a sheath. Irrespective of the syringe system used, three features are vital to any needle: the length, gauge, and bevel. These features determine the clinical characteristics of the needle, their safety features, and their indications. Let's go into the finer details now. The needle length is also called as the shank or the shaft. The length of the needle shaft extends from the hub of the needle to the tip of the needle. It starts at the bevel and ends at the part which penetrates the cartridge. Now, the length of the needle may vary according to the company as well as the country. But a typical standard needle can be of three basic lengths. The long one is typically 32 millimeters in length, short 20 millimeters, and ultra short 10 millimeters in length. Now, to a very important question of clinical importance. How do we choose the length of the needle for dental anesthesia? So here it is. The choice of the needle is based on the depth of tissue penetration that you require. So logically, you need to choose longer needles for mandibular nerve blocks, maxillary nerve block, including the anterior superior alveolar nerve block. While short needles are used for infiltration, intraosseous injections, intraligamentary, intrapulpal, and a few maxillary nerve blocks. The next important feature is the gauge of the needle. It refers to the diameter of the needle lumen. Now, this is a very important aspect that everybody needs to memorize. Higher the gauge, smaller is the internal diameter. So, if you notice carefully, the internal diameter of a 30 gauge needle is much smaller when compared to the internal diameter of a 25 gauge needle. Similar to the cartridges, the needles are also color coded according to the gauge. Red for 25, yellow or orange for 27, blue or lavender for 30. It is true that we have numerous gauges of needles available in the market, but just to make things simpler for us, remember 3 gauges alone. These are the most common gauges used in dentistry: 25, 27, and 30. So remember, the diameter of a 30 gauge needle is smaller when compared to a 27 and a 25. So the needles with larger diameter are 25 or 27 gauge, and needles with smaller diameter are 30 gauge needles. This should be remembered at every point of your clinical practice. Why should we be so concerned about the gauge of the needle? It is not without a reason, not a reason, many reasons in fact. Needles with larger diameter, especially the 25 and 27 gauge needles as far as dentistry is concerned, these needles allow for easier aspiration. They cause less deflection of the needle as they are inserted into the deeper tissues. Also, there is a less chance of breakage at the hub with these needles. Hence, these needles are the most recommended. Just to share something very interesting, there is a general assumption that needles with smaller diameter, especially the 30 gauge needles, are less traumatic than the larger diameter needles. Hence, it is generally assumed that bigger needles elicit more pain. But the fact is, it has been established through numerous studies that patients cannot differentiate between 23 or 25, 27 or 30 gauge needles. The gauge does not really matter. What matters is the rate of injecting the solution into the tissues. Here is a good correlation between the gauge of the needle and clinical purpose. Use 25 gauge, either long or short needle, for injections with high risk of positive aspiration. 27 gauge needles for injections with low aspiration or injections with low tissue penetration depth. And reserve 30 gauge needle for localized infiltration or hemostasis only. Now, here is a very interesting statement from the Master of Local Anesthesia, Sir Malamed himself. If I quote him, if only 2 needles were to be made available in my dental office, I would opt for a 25 gauge long needle and a 27 gauge short needle. I have absolutely no need or desire to ever use a 30 gauge needle for an intraoral injection. That explains it all. Like the color coded system that we have for cartridges and for cartridge syringe needles, we also have color coded needles for non cartridge syringes. Now, this is just a display of the various colors and the related gauges. This brings us to the next important clinical scenario in our country. What are the options in practice in India? So we can buy needles and syringes separately as blister packs. With this method, you can get needles of all gauges and lengths, so you can choose specifically. There is also an option of buying combo packs wherein needles and syringes come together in ribbon packs. But with this, we have very few options of choosing either the needle or the gauge. We can't really be specific. Just to make you understand better, here is an example of a ribbon pack. So with the pack shown above, The gauge of the needle is 24 and the length of the needle is 25. You do not get to choose a different length or a different gauge. These come pre-packed in specific dimensions. It is also important to understand the difference in the needle lengths between a cartridge and non-cartridge syringe needle. A long needle of a cartridge syringe is 32 millimeters, while a long needle of a hypodermic syringe is 38 millimeters, like what is shown here. Remember, most of the textbooks refer to cartridge syringe needle when they indicate the desired depth of tissue penetration. So if a textbook says 3/4 of a cartridge syringe needle, you can't use the same measurements for hypodermic needle. If you did, you're going to penetrate more, leading to potential complications. The next important feature of a needle is a hub. It is a plastic or metal piece through which the needle attaches to the syringe. This is the area where the needle and the adapter meet. On the interior surface, a plastic hub is not pre-threaded. So here, the needle must be pushed onto the syringe, while with a metal hub, needles are pre-threaded. Hub happens to be the weakest area of the needle. So adequate safety measures must be taken while inserting the needle into the tissues with specific concerns or attention towards the hub area. So an important safety rule is not hubbing the needle, which is not pushing the needle into the tissues till the hub area, because it generally fractures at that region. Also, check for the glue point, especially with a plastic hub, and the batch also, because as it gets delayed, as it gets older, the glue point becomes weak and leads to disengagement. Moving on to the third important feature of a needle, the bevel. It refers to the point or the tip of the needle which helps in penetrating the needle into the tissues. The bevel may be of various types depending on the length and also the facets created. Based on the length, it may be short, medium, or long, and based on the facets, it can be multi-beveled or scalpel beveled. Greater the angle of the bevel with the long axis of the needle, the greater is the deflection of the needle as it passes through the soft tissues. The clinical implication being missing the target area with greater deflection of needle. So that is why today we have non-deflecting needles which have favorable bevel angles in comparison to conventional needles. The other important clinical aspect to remember regarding bevels is this. For most injections, the bevel of the needle is oriented towards bone. In recent years, scalpel bevel has become very popular because of its smooth penetration, less tissue displacement as the needle is driven through the tissues, requires less force, reduced deflection with better control and accuracy, and reduced discomfort to the patient. Let's now move on to needles with special features. To begin with, the XL needles. These are needles with really large bore, up to 43% more than a standard needle. But what are the advantages that these needles offer? These require less pressure for injection, less pain is elicited while injecting, and these give better aspiration ability. Then there are needles with bevel indicators. Now that we know the importance of bevel, like I mentioned before, for most of the injections, the bevel needs to face the bone. But it is impossible to find out the angulation or even the orientation of the bevel once the needle has entered the tissues. Hence, bevel indicators have been incorporated into the needles to help orient the needle for different injections. So a few of the indicators are shown here. Indicator can be in the form of a red dot or like a triangular indication. But with a hypodermic syringe needle, you do not have any bevel indicators. We also have special needles for children, which are indicated by specific colors. Purple cap for pediatric patient. These needles are typically short because short needles induce less fear in patients. The next innovation in needles include the bendable needles. Quite contrary to the general opinion that needles should not be bent while injecting local anesthetic solution, the proponents of this technique advocate bending the needles in a safe manner. This is referred to as the Tuttle numb-now needle. These are special needles used with the specific Tuttle numb-now technique, particularly for difficult to numb teeth. So these needles use an intraosseous injection method which can be used with a standard syringe. These needles have a specific needle guide which is used to bend the needle. But the most important aspect here is the bending of the needle happens along the shaft and not the hub as with the other methods. The next novelty is safety needle. These needles serve the same functions as safety syringes, but the protective mechanism is a part of a needle rather than the syringe. In this way, they are completely different from the safety syringes. Simple cap needle system is one of the examples of safety needles. So these needles come in a capsule with retractable sheath. When used, the retractable sheath is pulled inferiorly, like what is shown here. When not in use, the sheath is pulled anteriorly to be disposed of. The biggest advantage is that these needles can be used with conventional syringes. Another type of safety needle which can be used with a non-cartridge syringe is what is shown here. These are hinge-based safety solutions, and these are activated with a thumb or a flat surface. And these elicit an audible click when they are locked, ready to be disposed. Another novelty in safety needles is the incorporation of a collapsible sheath over the needle. This is much more comfortable than the other types. Every time a needle is used, one must go through a checklist. A needle must always be inspected for integrity and imperfections, especially if bone has been contacted. One of the most frequent problems is that of a barbed needle. This results in significant tissue damage and patient discomfort. But it can be easily identified by pulling the needle through a sterile gauze pad. And if found, a barbed needle should definitely be discarded. Let me now move on to the more exciting techniques of injecting local anesthetic solution without a needle. Let's begin with cryoanesthesia, which is inducing anesthesia using ice. So you have cartridges or syringes filled with saline and stored in a freezer at a temperature of about -4 degrees centigrade and 0 degrees centigrade. And these syringes are applied to the tissues for a period of 2 to 5 minutes. These deliver dependable anesthesia of the tissues. These are simple and economical. The next needleless method of inducing local anesthesia is the use of intranasal spray. Covanase is a product approved by FDA to achieve the same. It is a combination of tetracaine and oxymetazoline, which is a vasoconstrictor. Two sprays are supposed to be given 4 minutes apart. The spray immediately anesthetizes the upper teeth, especially the anteriors and the premolars, without the unwanted anesthesia of the upper lip. So that way, it is very popular among the patients. Analgesia can also be achieved with the use of lasers. Low-level light therapy has been used to achieve successful dental anesthesia as well. Just like the local anesthetic solutions, low-level laser stabilizes nerve cell membranes. They can be used for the hard tissue as well as for the soft tissue, and they are ideal for pediatric patients. The last but the most popular method of inducing local anesthesia without a needle is the jet syringe or the needleless system. It works on a very solid principle. When liquids are forced through very small openings called jets at very high pressure, it can penetrate intact skin or mucous membrane. So that is what the system uses. The primary purpose of these systems are to obtain topical anesthesia before insertion of a needle or to obtain mucosal anesthesia of the palate. The commonly used jet injectors in dentistry include the MedaJet, Comfortin, and Injex. The major advantages include, in addition to these not requiring a needle, delivering very small volumes of local anesthetic solution, less than 0.3 ml, which practically negates LA toxicity. The solution penetrates the skin and mucosa at a depth of about 2 to 2.5 millimeters in milliseconds. This is a comparison between a conventional syringe system and a needleless system. Which patient wouldn't want this needleless system? Having said that, jet syringes do have certain disadvantages. So these are inadequate for pulpal anesthesia or for regional block. They do not support the traditional dental local anesthetic cartridge. They can cause discomfort due to pressure. The cost is another factor, and there is a possibility of damage to periodontal tissues. And also, these are known to cause post-injection soreness of soft tissue. Now, I'm going to demonstrate administration of local anesthetic solution using a pressure syringe. The system used is the Inject's needle-free system. Injects can be used either with a multi-dose vial or a cartridge. For use with multi-dose vial, these are the components required: a reset box, injector with spring mechanism, ampule, which has a nozzle diameter of 0.18 millimeter and a silicone tip, vial of local anesthetic solution, and vial adapter. A nozzle of such a small diameter is needed to create a jet of local anesthetic solution. The ampule is disposable, while the silicone tip is autoclavable. For use with cartridge, you need a transporter. The transporter is used to place the cartridge from where local anesthetic solution will be loaded into the ampule. But my demonstration of the system now will not use a transporter because I'm not going to use a cartridge. Instead, I would be using a multi-dose vial of lignocaine. Now this is a reset box which is used to activate the spring mechanism in the injector and gets it ready for use. This is how you activate with the injector inside. This is the injector which is used to deliver the solution in jet form. That's a lever to activate the pressure chamber within. This is the safety ring to prevent accidental discharge of the injector. The ampule carries the LA solution. This is disposable. And this is a silly tip. It is soft. And this is the structure which contacts the patient's gingiva. And this is autoclavable. The capacity of the ampule, as you can see, is really small, 0.3 ml. This is our standard multi-dose vial. This is a vial adapter to facilitate transfer of local anesthetic solution to the ampule. That has a needle which pierces the rubber top. Now we're going to start with loading the LA solution. I'm securing the ampule now to the vial adapter by firm twisting motion. Now I'm drawing local anesthetic solution into the ampule by withdrawing the plunger. You can see the local anesthetic solution entering the ampule. A volume of just 0.3 ml. That's the ampule fully loaded. Once it's done, you remove it. Now the autoclavable silicone tip is applied to the end of the ampule. Remember, this is the part which comes in contact with the patient's gingiva. It is really soft. You see the nozzle, tiny nozzle. Now we're going to load the injector into the reset box. Remember to set the safety ring to on position. It's in the on position now. Position it inside the reset box. I'm beginning to activate by closing the lid. Now the injector is all set, activated. The safety ring is now changed to off position. I'm going to load the ampule now into the injector by simple twisting motion. Make sure it's firmly seated, and now it's ready to use. The injector needs to be in contact with the tissue during administration. That's very, very important for effective anesthesia. That's the activation of the injector. See, the lever expels a stream of local anesthetic solution. Absolutely needleless. This is in slow motion. Once again, for a closer look. That's the way 0.3 ml is expressed. Now the ampule is removed after usage from the injector and discarded, while the silly tip can be autoclaved for next use. The last in the list of local anesthetic delivery systems is the intraosseous delivery system. So these are devices that inject local anesthetic solution directly into the cancellous bone, very, very close to the root. So the advantage being rapid and effective anesthesia by delivering the anesthetic directly closer to the nerve tissue within the bone. The common systems used are Stabident, X-tip, and Interflow. The important components of the intraosseous LA delivery system are the drill bit, which creates a small perforation within the bone, and the injection needle, wherein a needle fits within the drilled hole to deliver local anesthetic solution. The biggest advantages of intraosseous LA delivery system include the fast onset of anesthesia because you have direct access to the nerve within the bone. Reduce anesthetic volume because these require only 1/4 to 1/3 of a 1.8 ml cartridge. Minimal soft tissue numbness because the effect is localized. It does not reach the lip or the tongue. And it provides single tooth anesthesia. The potential disadvantages being technical difficulty and the potential for discomfort while injecting because of the drilling process. Also, the risk of bone damage in certain scenarios. The Stabident system comprises of a slow speed handpiece driven perforator. What you see here, it is a solid 27 gauge wire with a beveled end. When activated, it drills a small hole through the cortical plate. The anesthetic solution is then delivered to the cancellous bone through the 27 gauge ultra short injector needle, which is placed into the hole made by the perforator. Some people initially had difficulty in placing the needle of the local anesthetic syringe back into the previously drilled hole in the interproximal bone. So, introduction of X-tip eliminated this problem. The X-tip system has an additional component, a guide sleeve along with a drill. The X-tip anesthesia delivery system consists of an X-tip that separates into two parts, the drill and the guide sleeve component. The drill leads the guide sleeve through the cortical plate, whereupon it is separated and withdrawn. The remaining guide sleeve is designed to accept a 27 gauge needle to inject the anesthetic solution. After the solution is injected, the guide sleeve is removed completely. Despite the advantages offered by intraosseous injections, one needs to be careful. Because intraosseous injections deposit local anesthetic into a vascular site within the bone, it is suggested that the volume of local anesthetic delivered be kept to a recommended minimum to avoid possible overdose. In addition, because of the high incidence of palpitations noted when vasopressor containing local anesthetics are used, a plain local anesthetic is recommended if possible. With this, we come to the end of this lecture, and here's a summary. The critical features of a needle are the length, gauge, and bevel. Long needles are used for mandibular blocks and maxillary blocks. Common gauges used are 25, 27, and 30. Greater the bevel, greater the deflection of the needle into the tissues. Ensure absolute safety during usage and avoid cross-contamination. Intraosseous needles are ideal for single-tooth anesthesia. Consider needleless techniques for children and patients who are needle phobic. Thank you.